Hello, everyone. Many thanks for the great introduction here. So I will start by saying the following. What if I tell you that the multi-agent systems will fail? Because everyone today, it's really enthusiastic about multi-agents. Yeah, really everyone, it's doing it everywhere. But in practical use cases, we've seen that this is basically failing for such use cases like workflows, which really require strictness than creativity. And I think this is really important because this doesn't seem that it's a stopper at all. Yeah, it's just fine, and you will see in the next, why this is just fine. I'm Catalin Novac. I'm ML and AI lead in Danubia Advanced Center, lead architect on some of the engagements that we have at Accenture, especially into the Gen AI area and AI area into the automotive. And in today's talk, I will mainly explain a bit what Agentic AI is and how you can actually use this Agentic AI also into the multi-agent systems and engage these agents, such that they can really do something meaningful. And I like one of the slides before of Emmanuel saying about creativity and productivity. This is a really great one because in the end, this is what it's about. Even though the multi-agent systems, they don't have the fully autonomous capability yet, and we are not there yet and will not be there soon. At least that's my perspective. Will be more some years to come until we really get to have fully autonomous agents that can work. Even though this is not yet there, this doesn't mean that we cannot be productive and we cannot get efficiencies. And this is what I will discuss today mainly, to see how we can have these agents, even though they're not fully autonomous, how they can really help us and make us more productive. So Agentic AI, Agentic AI, and I think maybe most of you who are technical guys in this round have built some agents or assistants or co-pilots, however you would like to call them. And basically, you have this kind of waterfall or scripting approach, where you have this LLM as a central core of any agent out there, and then you have some prompting that it's happening the generation, then you have some memory and some tools to use. For instance, and I think this is the most famous pattern that we see all over the place, especially into the enterprise, the retrieval-augmented generation pattern. There you have tools to search over the knowledge, to search over different things, or even execute. So usually the tools are not only for the retrieval part, where you have also the memory, which is helping your agent to keep track of the interactions, but also acting like hands, really like hands of the people out there or of the agent to execute things. I don't know, create a Jira ticket, create an article on Confluence, and what's not. But the agentic approach comes here into play in terms of especially question answering, to come with one component which is so-called planner or planning or reasoning, how usually the industry it's calling this. This planning capability brings a couple of prompting techniques, but it's not only the prompting technique like chain of thoughts, tree of thoughts, reflection, for instance, which is a really nice design pattern. I will explain a bit what that means. It's more behind this, because it's not only the LLM part and the prompting technique, but you also have some engineering behind, because you have multiple iterations. So really, this looks like, if we do the analogy with the project management delivery, the left side, the zero-shot prompting, more like a waterfall one, and the other one looks like agile, if you want to code like this, into more iterative approach. And I think what is really important about this, has been identified. There was a research there that it's identifying, or has identified, that the models like GPT 3.5 employed in a multi-agent system can outperform the bigger ones. And I think at this stage we are more or less on a limit in terms of scaling more and more the models, because even though the models are bigger, it doesn't seem they become better. And we have seen that specialized small models out there usually outperform the bigger ones. But if you also employ them into so-called multi-agent, so that you can let them work together in different, so specialize them and put them together. And that's why this multi-agent, it's so important, but has some limitations. Yeah? I will explain about them. And this is what is important about this benchmark, which was actually created by the deep learning AI community out there. It's saying that the GPT 3.5 on this benchmark on human eval, yeah, which is really known benchmark out there in terms of evaluating large language models, it's outperforming GPT-4 by far. Just employing it with a proper agentic approach, with proper technique out there, plus bringing it into a multi-agent approach, yeah, connecting them together. That's why I think it's important to discuss about the patterns, because you can bring them in multi-agent systems, but if you bring them and you just let them run autonomously, this will not work usually. And I will have an example in a later stage, yeah, to show how this can be done properly, that brings some efficiencies. For now, what I would like to talk is about some patterns, design patterns about agentic AI, and one of them is actually the reflection, which I think is really important, because there are several research papers behind this, but this has actually shown that this iterative process of prompting the LLM in a certain way to reflect and have another one to actually critique the response, it's bringing much better responses in the end. And of course, there is a fine gray on how you stop this, when you stop to reflect, when you stop to critique, you know, to this. And there are some metrics out there that you can actually leverage. That's why I'm saying that it's also coupled with the engineering approach on how you stop to reflect and make sure that this is actually bringing much higher accuracy and really reducing the hallucination, because we have heard before on the previous speakers as well, right, on this one. And this is also really linked also with the planner. You know, the planning itself, it's also bringing this capability of, if you have multiple agents out there, you can actually assign tasks and plan the task and breakdown, because usually the multi-agent systems are quite good on multi-hop questions answering. Yeah? So you have multiple steps that has to happen before really answering the question. And that's why the multi-agent usually it's used, for instance, in research, yeah, or data analytics, where you have to actually break down the problem in several pieces and then have specialized agents that can work and actually fulfill the task afterwards. They can debate, they can put things together and validate afterwards. Yeah. So this is the approach. The other one, which is I think it's also was used before, but the tooling in this specific context brings actually the grounding of such agents. Because if you just let them by the LLM and give them the context without giving them real data or real-time data out there, or let them interact with the environment, then you cannot make them reliable. And that's why tooling and having a reliable function calling capability into LLMs, it's also really important. Yeah, we have seen with the latest ones that this is becoming quite reliable, yeah? And also especially besides identifying the functions that you have to call, but also to have a structured output out there, like JSON or XML or Markdown, for instance. Yeah, with some tweaks, I can tell you, but still, it's becoming much more reliable, yeah, than before. So now you can really bring them into a multi-agent system because they are becoming more and more reliable. And of course, the last one, which is basically coming with the multi-agent system approach, where you have these well-defined patterns or communication protocol between these agents. And you will see in the later stage how you can actually evolve this beside having a framework that it's doing this with custom agents, which are actually connected with the LLM, so the previous architecture, but bringing this to a so-called, we call them still agent, but apps, yeah? Which have the same structure, but in the end, they're actually APIs behind the scenes. So they're encapsulated in some sort of APIs that they have the same structure, the same communication pattern, and then you can actually override, yeah, the framework to use the apps behind the scenes instead of really agents. Yeah? Now, in terms of planning and collaboration pattern, let's say, of the multi-agent systems, basically, there are two areas, yeah, where we see this. It's basically centralized and decentralized, because in most of the cases, that's why I said, and I will have some takeaways at the end, yeah, in terms of having a workflow. And we see this. If we think of software development lifecycle, you have certain steps that you have to follow. If we think about customer service, you also have certain steps to follow. Also data analytics as well, right? But it's becoming tricky if we employ too much and give too much autonomy. And that's why we have this kind of two sides. Centralized decision-making, when you have certain patterns like group chat or nested chat, which are actually concepts coming from the frameworks of multi-agent, like Autogen and the others, and decentralized. Yeah, decentralized decision-making really makes these agents also take decisions by themselves, but put them in a sequence. And also the planning and consensual process. And I think that's why it's also right now in most of the frameworks out there, it's actually in preview or in research or so, because this is the most dangerous one. Yeah? It's danger in the sense that gives really more and more autonomy to the agents. And this is where it's exactly what I said at the beginning, that they will fail. Because when it comes to workflow, and it's a strict workflow, you don't need creativity out there. Yeah? You don't need to change the flow that much, but you need to have to follow the flow and make sure that it's really reliable. In terms of frameworks, I think it's these are. I just depicted some of them. Maybe some of you have already used them, but I can give at least from 3 of them because I use them already. Just some hints, and maybe that would be helpful for you. Autogen. This is where I think everyone who started with multi-agent system actually used Autogen. Yeah, and I used it from the beginning and was a really cool one, but wasn't really able to really put it in production. The latest versions of this one was becoming much reliable, because Microsoft, even though at the beginning they have realized that this is so cool and it's gives really this kind of capabilities and have more reliability of different benchmarks, and in the end the benchmark they actually hard-coded in a way, the questions and so on. Still in production this is not working out, because it's exactly the problem that I said, too much autonomy. And that's why they have introduced these kind of patterns, and that's why we see those patterns. Otherwise we just see one pattern that leave alone, interact with the environment, and that's it. But that's why we have those patterns, because we have seen that this is not working out. And this is what Microsoft, I think they were actually the pioneers of these ones at the beginning, and the others were coming. And they have slightly different approach, I would say. In the sense that, for instance, LangGraph, it's basically usually using a graph behind the scenes to capture the interaction, the flows, and so on, which is a really nice idea. But for building it gives you a greater flexibility, but it's also more error-prone, also more cumbersome to work with, at least from my experience, but gives you really a lot of flexibility. It's kind of like a PyTorch for the LLMs and so on, so it gives you really a lot of flexibility, but sometimes you don't need this. Sometimes you need just basically the high-level API out there that you can work with. QAI, it's actually the new kid in the block, let's say, for some months already, maybe a year or so, which there was actually a company also built based on QAI, and that I think they're really good. And this is the latest one that I used, and it's probably the easiest one to use out there, at least from my experience. It's the easiest one to use. We have really well documented patterns there and how to use them and so on. Nevertheless, doesn't have that much flexibility as Autogen, for instance, and also they don't have there is a UI out there that you can interact and create, but it's not open source. LangGraph also being the UI. Autogen did it recently as well. It's kind of like a studio, if you want to call it, agent studio. But overall, I think all these ones, and even the Llama Index one has Llama agents. There are really good choices out there, and it's really depending what you have on the ground. If I would have right now Llama Index in all my implementation, I will use Llama agents. If I have LangChain in my implementation, I will use LangGraph, even though it's a bit more cumbersome, because it's interacting much better with the entire ecosystem that you have out there. And maybe that's important about the multi-agent frameworks out there, because as I said, not all of them are really suitable for enterprise yet. QAI, for instance, even though it's claimed there in the enterprise, we are actually working to put this also there. But we have faced some limitations already of this, in terms of autonomy, in terms of really making it work. They have a really nice interface in terms of expanding the agents or override and create a custom agent. But even so, it's not that easy. So that's why in the enterprise area, I think the multi-agent systems have a place, especially from my perspective, into gaining efficiencies, gaining productivity out there. Yeah? And in terms of the use cases that we have seen and built so far, yeah, at least 2 ones. We have built already the first 2 ones, Agent Store and the customer service. And we have global offerings here that we're working on from Accenture side. This is just an excerpt here. Yeah? The Agent Store, the data, the customer service, and the data analytics, but it's much more. Yeah? The research, I think it's probably the most used multi-agent system, at least in the research, the multi-agent system are actually the most used one. But in the enterprise area, the Agent Store, and probably you have heard about the OpenAI Enterprise, the Microsoft Copilots. Amazon has their Amazon Studio or Agent Studio as well. So all these studios, yeah, they are becoming much and more important into enterprises. Why? Because they are enabling all the employees in the company to either build their private assistant, and you have seen the previous talks as well, right? Having like your own UI, on AI as well, and I think that's really good because this brings you efficiency. And then even more, even though you have your own, and you can also expose to your small group or bigger group that you have out there, you can also make them work together. And that's really, really important because otherwise it would be hard for you. Either you're doing isolated and you're making silos, and usually this is what the big enterprises are actually trying to avoid, creating silos. Even though in reality we know that this is not the case. Yeah, we all know that silos are there. Yeah, and it's really hard to really break down those silos. But nevertheless, this is basically what is the idea of the Agent Store. Gives everyone technology at their hand to create their assistants, personal ones, and they can work. We can also even open them to the world and make them work together. And SDLC, so software development lifecycle, it's a use case that we are building right now, which we think it's actually quite good in terms of gaining efficiencies. Not replacing developers or engineers or so, because I don't believe this is true, but it's really bringing efficiencies. And I'll show in the next slide how the other companies think about this. I don't believe them, but that's another story. Customer service. It's a really nice example in terms of using multi-agent. The omni-channel experience, yeah, across the touch points out there, we have seen in many, especially in the automotive area, this, and I think it's not only there, this discrepancy between when you are in the website of the car or the dealer and you are in the configurator, or even more, or even in the car. We have seen that these touch points, these interactions, these behaviors, they are not connected at all. There is no way that they are connected today. And this is basically what we are bringing there with the new offering to connect them, having behind the scenes a behavioral graph of the user across the touch points, across the channels out there, and then use specialized agents to really make sure that the user has a personalized experience. Really feel that if I was going on the website and I was looking on on BMW side, I was looking on the 3 Series. You know? When I'm going to the configurator, it's already suggesting me 3 Series, maybe with some color that I was looking or what's not there. You know? So this is just a simple example on how this can evolve. Even more in the car, for instance. If you have already interacted with the customer and it's Halloween, for instance, you can give a push notification with a platform that you have seen before. Yeah? Give a push notification to the customer into the application, into the mobile application. Say, look, there is a surprise for you in the car, and then the whole theme of the car, the head unit, the lights, and everything, it's actually into Halloween. You know? Because you have seen and interacted with the customer and know the behavior of the customer. Changing and also generating for instance, the background of the head unit. This is also parts of what we're building here into so-called omni-channel experience of the customer, especially into the automotive. And data analytics, I think it's pretty straightforward. Yeah, you have really this kind of data silos which are specialized, and then employing agents to really deal with that specific point will help you into a multi-agent system. Will help you to really bring this to a level that usually takes really much more time. You know? Now, in terms of enterprises, of claiming efficiencies. Yeah? We see BP, MIT, SAP, and so on, but there are much more there. But in terms of software development lifecycle, for instance, BP is saying that they have actually gained 60 to 70% on efficiencies for software development lifecycle. Honestly, hard to believe this one, because from my experience and our experience in general into this area of software development, usually it's 30 to 40%, it's the most realistic one. Yeah? But having already some prerequisites, an agent store already or a GPT store already there, having multi-agent ready agents there that you can employ and so on, and this is basically where you can get to the 30 to 40%. Having GitHub Copilot, I know, Cursor or Amazon Q, yeah, which is already helping developers to develop the code, then would make sense to have 30 to 40%, because otherwise it's really, really hard, unless you're really doing really script type out there, and then it's fine, yeah. But in the normal software development lifecycle, for front-end to back-end to infrastructure to anything, you need to have specialized agents. This is the only way that you can do it, and that's why also the benchmark that we have seen at the beginning, it's so important, because we have seen that even though you have smaller models out there, not that capable, bringing them into a specialized form, and this is well known about the LLMs in terms of capability and limitations, they can be really good and specialized, but usually this is not enough, yeah, because everyone is just looking for AGI, but I believe this will come or may come, I don't know, in years, even more a decade, yeah. So that's why I think, from my perspective, these kind of numbers, I will take them with a grain of salt, to be honest. But it's still a place there. Exactly what I said. This doesn't mean that if the multi-agent systems out there are not, fully autonomous, and we may have time, we may take time to get to there. This doesn't mean that we cannot get efficiencies. And I have a demo for this that we are actually building today on an automotive customer. And before really starting this video, I hope it's really visible, not that much. I can do GNR, but I cannot do this. Before starting with this, one of the prerequisites, exactly as I said about the GPT store, and this one, it's basically having a workflow builder, because workflows, I think they have their place there. That's why this kind of group charts, sequential collaboration and so on, it's so important into multi-agents, because they can let you drag and drop, like here, yeah, 1 second, like here, they can let you drag and drop, orchestrator, planner, DevX, which is actually the developer experience, infrastructure, operations. You have many out there that you can bring together specifically for your project. Yeah? And that's important, because the workflow itself, and I'll just stop for a second, the workflow itself here would be basically coming kind of like your product owner or architect. So the team that it's actually knows the best the project that you're out there, and it's connecting your project configuration, your project documentation, and also the company policies out there and processes in terms of software development, in terms of UI development, backend development, and what's not there. And that's important, because usually this is one of the biggest lacks that we have seen in most of the SDLC implementations out there, that you don't have this kind of common or shared memory across the agents that you can, pass by and give them the agents the whole context of the entire project. And that's why you may, I'm not sure if you've seen it, but there is a version for each and every agent here. It's basically the version of the agent gives you the capability to have multiple versions of that specific agent that you can employ in the workflow, and gives you the capability to customize it more for that specific agent, and also see how it's behaving into the workflow. Yeah? And here you will see that just on a test, but it's really hard to see, unfortunately. Into the example that we have here on the demo, we basically have built a car credit application agent or assistant that we started just with a high-level requirement. Yeah? And you will see right now, usually this is every project that is starting under. You're starting with the high-level requirement, and then you have a Confluence page or not, and then everything has to break down epics, feature documentation. Everything has to start from that. Yeah, and this is basically what we did here in terms of generating the high-level features out of that Confluence page. then validate it. You will not see here the validation with the human because of the time and with the video. But usually this is validated with the human, the functional requirements. Once you have the functional requirements, then you can build epics out of those functional requirements. Then you can build functional tests out of that you can use always to make sure that the critical features of your application, it's always there. They will always be green, and this is really, really important because in most of the projects right now, this is not happening. You have just the functional requirements, and you just have them written, and everyone is more or less forget about them. And then you figure out at the end of the project, okay, this is actually what I'm missing. But this is what it's enabling such a workflow for you. It's basically enabling to have this kind of requirements already tested from the beginning, start with the TDD and BDD already in mind, behavioral-driven development, test-driven development, and then having also GitHub Copilot to help you develop the stuff, because the workflow here will not code for you, but what will give it's just a structure, the initial structure of the project with the functional requirements, with the unit tests for those. And then you can move this to your IDE as a developer, have the unit tests, and then start make them green. And this is, we know, all of us who are engineers here, we know that this is the biggest pain there, to start with the unit tests. Trust me, I think probably some of you are starting like this, I'm also not starting always like this. But this will give you, and this is what, from my experience, this will give you the highest accuracy or quality in any project out there if you're starting with the test. But you have other dimensions that you have to take care, timeline, and so on and so on. But this is exactly what it's enabling you. You don't have to care that much about this because you'll have all those unit tests from the beginning, and then you can just focus on really implementing the stuff using other tools. Because I don't believe that such a tool would be really helpful if you always have to context switch. If I'm going from an IDE to this, to code something or do something, then it's, from my perspective, it's not really bringing productivity. But I need to have at least a structure out there, give me already 30–40% of the structure that I can work with already and then already develop. And then having these agents that can help me to, for instance, validate the pull request. And this is what we see on the dev extension and the architect, that is giving me security hints that I have to look on my code, or maybe code quality, or maybe things that I haven't figured out. Before really going to a human reviewer out there, I can use this tool to just give me all these hints, and then I can be much better. I can become better. With the time, I can become much better. Even more, once you're doing the deployment or the CI/CD pipeline, having this kind of tool that it's giving you already the hints in terms of code quality that it's missing from the SonarQube report. So having this tool to analyze how your SonarQube or CodeQL report looks like and gives you hints on how to look for, then it's already giving you efficiencies, because otherwise the only option that you have is using ChatGPT or some other agent out there separately, right? But this doesn't know your company processes out there in terms of software development, and also not your project. So that's the overall concept of such, that can bring you even more to the operations. Some of the agents out there that we have built are actually looking on the real-time logs to try to identify errors, and then it gives you even suggestions on how to fix those things. And then you can take them and then implement them as hot fixes also. Next. Okay, now it's good. Good. So I think what is really important to understand from this, it's I would say maybe about the fact that agents are really nice. Multi-agent are even nicer, right? But you need to be careful when to employ them and how to employ them. If we think about strict workflows, we need to keep them. Like a real data pipeline out there, you need to keep that data pipeline there. This is exactly how it should behave. If you're introducing an agent completely on that and then give the autonomy on that, then you may introduce bias. And this is where I see, from my perspective, a case where we should be careful about this. Of course, the more creative the agent you give, the more autonomy you give, the more chances to failure out there, right? And what I would say it's really, really important is to always have at the beginning human in the loop. So always try to validate, and usually these kind of multi-agent frameworks, they have a so-called teaching capability. So once you give feedback, this is actually incorporated. Doesn't mean it's actually fine-tuning the LLM, yeah? But it's using this inside the memory, and then you can use this further. And that's really, really good, yeah? Because at some point, you can also fine-tune afterwards a specialized LLM for that specific agent, yeah? If that's really needed. Nevertheless, I think there are still two questions, really open questions out there in terms of security. And we have seen this, we have built safety checkers out there also for images, also for LLMs, but it's still, yeah, it's really hard to predict right now if you are really 100% secure or not. That's why there are specialized penetration tests in this area. And therefore, it's still an open question how you make it really safely, yeah, really. And nevertheless, yeah, what is also important about the evaluation. There are already some metrics out there for the agents themselves, but there are still in the research, let's say, the other type of evaluations for the multi-agent systems, yeah? How you really evaluate them properly. That being said, I would say that the multi-agent system at 70% are just enough, yeah? From my perspective, at this point, 70%, 80% is just enough to drive efficiency, to increase productivity in most of the use cases out there, and yet with no limitations, of course, yeah? Thanks a lot. If you have any questions, I think we have Maverick, Matt, how you call it? John, Tony? Yeah. Marnik.
Yeah, first round of applause. Thank you so much. Yes, we do have questions. I don't know if we can get it up here, or it's only on the screen. Okay. I'm just going to pick them out. Are you ready?
I was born ready.
You were born ready? Okay, thank you so much for the questions. I was so enthusiastic about the agents that I forgot to mention, but you can use Slido, but we figured it out. So I'm going to start at the top. Here we go. What are the projects where Accenture considered AI, but eventually decided to implement without AI, and why?
That's a good one. I think there are so many out there, especially on the critical systems on the clients, really mission critical ones. The AI usually it's either used behind the scenes, and it's not near real time or even real time, because it's too risky usually, especially for the automotive. It's usually too risky to have this real-time AI that it's predicting you and it's giving you predictive maintenance or so. And that's why you have seen also in the Confluent colleagues presentation that you have this analytics layer, or a state. And this is usually what we also do, because otherwise we put ourselves as Accenture in front there, and it's really hard to say, okay, this is really 100% secure. This is really 100% that will work out, because AI in the end it's just about probability, statistics, maths out there. So this is where we are standing today. And of course, engineering. So we don't forget about this. That's why, as long as you have a certain level of uncertainty out there, and will be anyway out there, we cannot say that we can put this just on a mission-critical applications.
Okay, makes sense. Very good question. Thank you so much. I'm sorry that I turned my back to you. What are the main issues that prevent a wider adoption development of multi-agent systems?
I would say it's about autonomy. We are not yet there to have fully autonomous agents, and will take some time. At least that's my perspective. Will take some years, maybe a decade. I don't know. To really have fully autonomous agents there, and that's basically what it's really preventing us today to have these multi-agent systems really at scale. You can do it on limited use cases like software development lifecycle or so, but also controlled. And I think it's really important that it also has to be controlled in a way that you have this kind of capabilities of putting them sequential or what's not. I think this is the biggest challenge. And I think anyway, if we'll have fully autonomous, will still be a challenge out there.
Who knows? Open Slava 2025. Maybe we have all the answers. It goes fast. And then the last one, here we go. Oh, it's a whole paragraph. Join me on this. Do you think we will have a problem in the future with these helper models agents because we are relying on them while coding? Because GitHub Copilot is trained on the code out there, which might even be AI generated.
Yeah, this will give a bit of a standard if you think about, especially about GitHub Copilot, I don't know, Cursor or Amazon Q. These kind of coder models out there, they actually train on huge amount of code that was out there, which has its own styling, its own way of doing things. And usually this is bringing, let's say, kind of like a standard. That's why, at least in the solution that we see there, it's basically to have these specialized coding models that helps you each and there, but not really takes you the whole stuff to code, because then you'll have the standard in your enterprise, you'll have the standard that everyone has it out there. And this is basically what you don't want, maybe. Maybe you have certain rules and processes in the company that has to stay there, that has to be implemented in this way, because there is a reason behind. Maybe a business reason, maybe a technical reason, maybe a technical limitation out of it. So this is where I see the, let's say, the place of the coding agents. That's why I don't believe that bringing another tool like this one and take you out of the context will gain efficiencies, but rather try to still be there, but use it for 30, 40, 50% if that's possible, to gain efficiencies.
Okay. I'm not even in the business, and I like that answer. I hope you like the answers. Thank you so much for asking the questions. Give a big round of applause.
Thanks a lot.
Thank you so much.